Well, it continues to snow on this glorious snow day. Outside it's cold and crisp, but inside Javier, the outdoor cat, is getting more and more bored. He's taken to reading the textbook, so we're going to get back to it and talk about 6-4, analyzing graphs of polynomial functions. And yes, I realize the cat thing is extremely corny. I really don't even like cats. He's my daughter's cat. But at least it helps the time to go by. All right, 6-4 is about analyzing graphs of polynomial functions. So on my calculator, I graphed three different fourth degree equations. A, the leading coefficient, is greater than 0 on all of these because they are coming from above and then returning to above. If A had been less than 0, we know they would have been upside down like that. And the question is, how do you know when you see the entire graph of a fourth degree equation? The first graph is pretty easy to identify as a fourth degree equation because it has 4 real zeros. 1, 2, 3, 4. And at most, a fourth degree equation can have 4 real zeros. Part of that is because if it's fourth degree, think about the little factoring groups that you would need to multiply by to get this equation, all of them starting with x, and when you would multiply this out, you would end up with x to the fourth. Also notice that since you have 4 real zeros, you also have 3 turns in the graph. Here's it turned around to come back up, there's one turn, and then it turned around to come back down, it turned around to go back up. So you have 3 turns in this graph. Why is that important? Because when you look at the next equation, the next graph, you might wonder, well, I only see 2 real zeros. Am I seeing the whole graph? Well, you still have 3 turns. Here's a turn, 1, 2, 3. So you've got 3 turns, which means you're seeing the entire graph of this fourth degree equation. Sometimes you just really can't be sure, like the last one. This one is also a fourth degree equation. You see 2 real zeros, but really only 1 turn. That's because the other 2 zeros are imaginary. How do you know? You don't always know for sure. You just graph around as much as you can. You could know for sure by dividing out the factors that you see. If you divide out the factors that you see, then you would be left with a quadratic, and you would check that for imaginary solutions, and if they were imaginary, you would know that indeed it was your fourth degree equation. But that's enough for now. Let's move on. All right, example 1, graph a polynomial function. It says to graph f of x by making a table of values. Now, most of you are going to say, do I really have to make a table of values? Can I use my calculator? And my answer to that is yes, you can use your calculator as long as you are careful about the table or the values on your table that you choose. For instance, notice that at -5, we are way down at -685, and then at 5, we're way down at -415. Now we know that this should happen because it's a fourth degree equation, and it's a negative a value, and so it should be starting down and then ending up down. Now what about in the middle? You are wanting to make sure that you see where the graph peaks. And we can see that our graph peaks about right here. And so that is also included on our table of values. If there was more than one peak, we would want to make sure that we included both of those peaks in our table. So again, you can use your table on your calculator, but be careful about the values you choose. You want to show where the end behavior is, and you want to be showing where the maximum or the minimum is in the function. Okay, go ahead and check your progress. So here is an acceptable answer to check your progress, number 1. By the way, if you choose mode and go to graph table mode, you can get both the table and the graph on your calculator at the same time, which is kind of cool. And you can see that down at 5, we're way up at 464. At -5, we're way up at 674. We can see that we have y values that go all the way down to -10, where we're seeing it looks like we're close to our minimum value there. And so we're pretty sure that this is a good table and graph of this particular function. On to example 2. The next part of this section talks about locating the zeros of a function while looking at the table. Now the idea is that if y is positive, like here, and then in the next one it's negative, then the graph must have crossed somewhere between -5 and -4, because at -5 it was way up at 37, -4 it's way down at -23, so in between there is a 0. So in this particular table, you can see that there must have been a 0 here. There's another one there in between those two values. Then it's positive, positive, oop, 0 right there. Negative, 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 ooh, 0, and it jumps up really fast. So this particular, I don't like how I made that a double. I'm going to make that a single, like that. So this particular function has 1, 2, 3, 4 zeros that we can see on this table. All right, example 2. So example 2 says locate the zeros of a function. They tell you that it is a third-degree equation. So when you look at your table, again, right here you see a change from negative to positive, from positive to negative, from negative to positive, indicating 3 zeros, which tell you that you have a pretty complete graph of the function. Because it is third degree, it can have at most 3 real zeros. Go ahead and try the check your progress. The answers to check your progress, number 2, that you should have found zeros between 0 and 1, and 3 and 4. Okay, the next section of reading is about extrema. What are extrema of a graph? They are just what they sound like, the extremes of the graph, the maximum, the relative maximum, the minimum, the relative minimum. What are these things? Well, words like minimum and maximum you already know and understand. For instance, the minimum of the function is the lowest point of the function where the y value does not get any lower. And even though that is the minimum, you also cannot deny that this is another minimum area of the function, not the minimum, but it is a minimum, and so we call that the relative minimum. In this function, we also have a relative max right here. What is the maximum of this function? There's none, because it is heading up to infinity on both end behaviors. We're heading up to infinity, and so there is not a maximum on this function. Your book also talks about turning points. What are turning points? Well, they are the obvious. The points where the graph turns, which would again be at maximums, minimums, relative maximums, and relative minimums. That is where the graph turns. Example 3, maximum and minimum points. Your book wants you to use your table. I would prefer that you calculate the max and you calculate the min, or the relative max and the relative min by using your calculator. Here are my two calculator screens from the equation in example 3. And you can see that I calculated the relative maximum here. Just a minute. There we go. The relative maximum here. And we would say the relative maximum is at the point negative 0.23, 3.24. However, understand that the relative maximum is the y value, and the x value is where it is located. So just be careful with that. Then we can, and also for this particular function, there is no maximum. How do I know that? I know that because it is degree 3, and I see 3 real zeros, which means this is never coming back down again. It's going forever upwards towards positive infinity, so there is no maximum. Now looking at the relative minimum, you can see that I calculated it, the relative minimum, at the point 2.90, negative 12.05. The actual relative minimum is y equals negative 12.05, located at the x value 2.90. Notice that I tend to round to the nearest hundredth. In general, you should round to the nearest hundredth when you are not instructed otherwise. Okay, do the check your progress, number 3. Okay, I hope you stopped the video, and the answers to the relative minimum are 0.67, negative 3.63, and the relative max is at negative 1.1. There is no actual minimum or actual maximum. All right, on to the last example. Before we go on to example 4, in that little box above it, or excuse me, it's not really a box, in the little graph above it, it starts to talk about increasing and decreasing on the function. Now, the function is increasing if you put your pencil on the function, and as you move left to right, you are going up, you are increasing. And so the function is increasing all the way from the beginning up here to the first relative maximum. So you always talk about intervals of increasing in terms of x. So it is increasing from negative infinity for x, because you're going actually this way, even though just you can't see it because you've got to stay on the graph. From negative infinity all the way up to the x value here, which is negative 1. So when x is less than negative 1, the function is increasing. Now, as we continue to go from this relative max to the next relative min, we are now decreasing. So the x interval is decreasing when x is greater than negative 1 and it's less than 0.67. Now after we leave 0.67 and we head up the hill, we are now increasing again, and so we now have an interval of increasing when x is greater than 0.67. Notice I didn't say less than or equal to, because at the actual relative min or the relative max, you're pausing. You're not increasing, you're not decreasing, you're like stopping so that you can turn and go the other way. That's where the turning points are. And later you'll hear that they are also called points of inflection. The last example I think is pretty self-explanatory. They have you graph a function. It's about going to the movies. You describe turning points. So here's turning points and end behavior. What trends in movie admissions do these suggest? If you look at the years where people quit going to the movies, you might remember, well, actually 30 years since 1926. So in the 50s and 60s, not so many people went to the movies. Then it started to rise again, and now it's going down again in 1996. Do we think the trend will continue indefinitely? That is a value choice you have to decide. I think with Netflix and things like that, it is fun to go to the movies, but probably people go a little bit less than they used to. Go ahead and try check your progress. The answers in red are the answers to check your progress. Take a look at them and see if you have any questions. Check your progress for A is here, for B, for C, and for D. Well, that's it for this section. I hope you understood it. See you in class. Bye-bye.